Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of second secondary, we are going to continue chapter 3 bonds and forms of molecules. We have many kinds of bonds we are going to illustrate. The first one, we said that we will continue ionic bond in our lesson. Okay, let's start. Okay, what happened in the ionic bond? As we start to say, we will make a revise shortly for some points that we discussed previous. Okay, the first one we said, what about ionic bond? Ionic bond formed by complete transfer of ions or one or more electrons from one atom to another atom, forming ionic, electric, or electrocovalent bond. If we make a transfer for bond or electrons between two kinds of atom, we form ionic or what, or electric or electrovalent bond. Okay, we will to continue what about the bond here. Okay, what about ionic bond? We have example for this one. We have sodium fluoride, its name sodium fluoride. By changing, we said that we remove electron, or the sodium atom lose one electron and change into positive ion or cation, and fluorine gain the electron that loses by the sodium atom, forming what, forming sodium fluoride. Its name sodium fluoride. We have this one, or this is an example for ionic bond. We have another one, sodium chloride and calcium chloride. Calcium, its valency has only one valency, so we not saying Latin or Roman number, so we said calcium chloride. Another one, we have magnesium oxide. All of these are examples of ionic bond. Calcium sulfide, we have sodium sulfide, and many kinds of these examples we have. What happened to move electrons? We have here losing of or transferring of electron from sodium to ion. We have here example sodium fluoride. Okay, another one, we have the transferring of electron from one atom to another. So sodium loses its outermost electron and fluorine gain one electron to attain stable electronic or octet configuration. Okay, we have example sodium chloride here. One electron transfer from sodium to chlorine, forming sodium NaCl, Na plus. We write this as Na plus Cl negative. We have CaCl2 as calcium loses electrons. This is we called Lewis dot diagram. Okay, we have here CaCl2, Ca give one electron to chlorine and the other to chlorine atom, so it's a dot Lewis dot diagram, or structure will draw as it is. Okay, okay, what happened to form the ionic bond formed, or its formation favored between metals of group 1 and 2, as they have lowest ionization energy or enthalpies, and non-metallic or non-metals of group 17 and 16, as they have highest electron gain enthalpies or energies. As we said, we study in the first term that we have ionization energy. So what happened to make a stable ionic bond or ionic compounds between the first and second group and group 17 and 16 of non-metals? So we gain, or we make this kind of bond between the first and second in the lowest ionization energy, as they have the ability to lose electrons, as each one have one or two electrons in their outermost energy level, and the other nonmetal in the other side, in the other side of the periodic table, has highest electronic gain, as it gain 1 or 2 electrons to make the ionic bond or to make a compound with high stability. Okay, we say the electron gain processes may be exothermic or endothermic, as the bond loses the electron, and always, or in many of, or sometimes maybe exo or endothermic. Most of them will be endothermic at the end of reaction, so ionic bond will be formed more easily between elements with low ionization energy and the element with high or negative value of electron gaining energy, as positive ion and negative ion at end. Okay, electronegativity difference between the positive and negative. Okay, since a complete transference of electron from one or from the less electronegative atom is required for the formation of ionic bond, the electronegative difference between the atoms forming the bond must be appreciably high or extremely high, as to make a stable state for the bond. So the lattice energy or lattice enthalpy for making the ionic bond, giving example of sodium chloride in ACl, has high lattice energy, as it make high energy to move or to form the ionic bond. So salt or table salt is the most stable ionic compound that we formed in our life. Okay, as we see, it's around us in everywhere. We have table salt in NaCl. Okay, as we see in the diagram, we have the lattice enthalpy or lattice structure of sodium chloride Na plus Cl negative. Okay, what are the properties of ionic compound that we want to know? We want to know the properties of ionic compound. The first one exists in only physical state, the solid state. The other one, crystal structure, or ions arranged in a regular pattern. The third one, here we have high melting point and boiling point, as we say before, and soluble in polar solvents, all polar solvent, and the main of them is water, not soluble in non-polar solvent as or like benzene. As we say, we have, or they are good conductor of electricity in molten and in aqueous solution, so it is the main property for the ionic compound, and all 5 properties are the main for ionic compound. The last one, ionic reactions are fast, happen very fast, to make any of them soluble or make any of them able to make the reaction inside the lab. The last one doesn't exhibit isomer, as they don't have any ability to make another compound that's similar in the properties but different in the structure or converse to it. Don't have this one. So ionic compound have many properties, like the 7 properties that we studied or that we mentioned before. Okay, we have different questions or main question about our discussing for this: why sodium chloride is bad conductor of electricity in its solid state. Okay, we said before that we will have an essay question, and it's kind of questions that depend on the understanding of any point in our syllabus. Okay, that the first one here, why it's a bad conductor in its solid state, as it not conducting electricity or isolator. As in the solid state, sodium Na plus and chlorine ions are not free, or they are in interacting between each other, so the ions or electrons are not free. Okay, another question here: why silver nitrate gives a white percepted with sodium chloride solution but not with calcium tetrachloride? Okay, we have here another point that we have to discuss. Okay, I give you the more difficult questions at first. Why? To understand and repeat these questions until the exam. Okay, we said that we have ions free in case of electric conductivity, as here we have the sodium chloride reacts with silver nitrate. Okay, what happened to make reaction between them and not with carbon tetrachloride? Okay, we have the answer here: sodium chloride is ionic compound, as we have ionization in polar solvent or make dissolving in water. So the ions free of chlorine combined with silver, okay, of silver nitrate to form white precipitate of silver chloride. We take this reaction in third prep. Okay, but we make a compare here today between carbon tetrachloride and what, and sodium chloride. Okay, in our comparing, I think you understand now. We make a comparing between reaction of one compound is ionic and the other is covalent. Okay, so if we make the reaction between two ionic compounds, that will make exchange of what? Exchange of valences. As we said that we make substitution reaction. It's a kind of reaction that we studied before. But here we have a covalent compound can't make or doesn't give chlorine ions by ionization to form precipitate, or it can't be dissolved or can't make ions to make the reaction, as it's a kind of covalent compound can't be formed into ions. So there is no reaction happen between carbon tetrachloride and what, and silver nitrate. I think it's very important question to us. Okay, please study hard these points and try to mention different, I will give you different comparison between ionic and covalent compound in making the reactions. We have another question. Okay, we will have some choices question. Let's start. We have the stability of ionic compound is due to, okay, we wanted to know the reason. The first one, we have a potential energy. Second one, kinetic energy. Third one, hydration energy. And the last one, high lattice energy. Okay, you think the right answer will be what? Will be due to the high lattice energy. It is the right answer for this question. Okay, I think it's easy. You have to know every kind of questions. Okay, we will, in the next session, I collect to you questions of Egyptian Knowledge Bank and we will answer this one. Okay, let's go. We have question number 2 says that an ionic solid is a polar or poor conductor of electricity because the first one here, ions don't conduct electricity. The second one, charge on the ions is uniformly distributed. The third one here, ions occupy fixed positions in solid. The third one, ions have uniform field influence around them. Okay, what happened to make a ionic solid poor conductor of electricity? Do you think the right answer here will be what happened to it? The right answer will be ions occupy fixed position in solid. As we said, sodium chloride don't conduct electricity in its solid state, as ions stable in its solid state not make free ions. So the ion or ionic compounds may be, or in some cases may be poor conductor of electricity when the position of ions fixed inside the solid state only, inside or in the presence of solid state only as a physical state for the ionic compound. Okay, let's go to another question. We have ionic bond is favorable between atoms where X and Y. Okay, X has low ionization energy and Y has low electron affinity. Okay, we said one of them has high and one of them has low. What happened to them? Okay, remember well that we are discussing this point. The second one here, X has high ionization energy and Y has low electron affinity. Do you think that? We have the third one, X low in ionization energy and Y have high electronegativity. The last one here, X has high ionization energy and Y have high has high electron affinity. I think the right answer will be number C here. X has low ionization energy and Y has high electronegativity. So X low ionization energy as it has the ability to lose electrons easily as in group 1 and 2, and Y has high electronegativity as it has the high ability to gain electrons or attract electrons in group 17 and 18. Okay, let's continue. We have question number 5 here. The bond formed between cesium and chlorine is the first one here, covalent bond and ionic bond. We have dative bond, and the last one, all of these. Okay, cesium is a what? Is a positive metal or a positive forming a positive ion, is a metal forming a positive ion, so it will lose what? It lose one electron and change into positive ion or cation, and chlorine gain the other electron, so it will form what? It will form ionic bond. It will form ionic bond. Let's go to another question. Question number 6 says that the number of valence electrons in the ion of calcium carbonate, -2, or its valency divalent are, the first one here we have 8, we have 12, 28, and the last one we have 24. Okay, if we want to know the valence electrons here, okay, carbon is tetravalent as it surrounds by what? Surrounds by 4 electrons, and here we have the oxygen surrounds by what? Surrounds by 2 electrons that we want. It's divalent that need to gain 2 electrons. Okay, so we have here oxygen have 3, or make the valency of what? Of 3 or take 3 to oxygen, and here we have the valency exchange. If we make the exchange between them, so the number of valence electrons here, we have 3 atoms of what? Taken 3 atoms of oxygen to make the valency or the stability between them. So we have here the number of valence electrons will be 24 electrons. Okay, we will collect all the electrons 4 from the carbon, and here we have 2 times 3, we have what? We have 12. 12 times 4, we have 24. 12 here in the oxygen atom. 3 times 2, as we said, it's a divalent, giving 6. 6, and we have here 4 tetravalent from the carbon. 6 times 4 equal 24. So the number of valence electrons in the ion, here we have 24 electrons. Okay, let's going to another question. Okay, question number 7 says that in the formation of an ionic bond, we have electrons are transferred between metals, electrons are transferred from metal to non-metal, electrons are shared between metal and non-metal, and the last one electron pair is donated by one atom. Okay, what happened to form an ionic bond? One of them lose and the other gain, so the electron transferred between metal and non-metal, or from metal to a non-metal. Okay, another question. We have question number 8. Element X is a strongly electropositive element, and Y is a strongly electronegative element. Okay, one of them electropositive and the other is electronegative. Both are univalent, as uni means monovalent, so the compound formed by them would be, we have here the shape of the compound or bond that formed. We have number A, X plus Y negative, the other one X negative Y plus, XY and X arrow to Y. The third and fourth one will be wrong, but we have here X and Y. Do you think what is the right answer? Will be number A, as X strongly positive, as loses electron easily here, and the other one Y is what? Strongly electronegative, as it gained the electron, and each of them univalent, so the right answer will be number A. Okay, let's go to another question. The last question of our lesson today. The charge on cation M is plus 2 and the anion A is negative 3. The formula of the compound formed is, okay, do you think what? We will write M and above it plus 2, M plus 2, and above A negative 3. Okay, we make exchange for the valences. So A take or give 3 to the M. We have here M 3 and A 2, and the valences will be exchanged. Okay, so we will have the number 1 Ma2, also M3A2. Okay, do you think is right? Yes, I said we will make exchange here. M will give 2 to the A and A give 3 to the M. Here we have M2A3 and the last one M2A. So the right answer will be number B here, M3A2. Okay, this is the last question of our lesson today.